So in general, we could find a formula for the coefficients in Taylor polynomials. So what's the idea? The idea is to find the polynomial the function is going to have the form a0 plus a1 x minus a all the way up to the nth term an x minus a to the n. So which polynomial of this form best approximates the function f of x near x equals a? This video will show you a formula for the coefficients. So how do you find that? Well, if I plug in a to my polynomial and to my function, I should have the same value. So condition 0 is, if I plug in 0, so my polynomial is a0 plus a1 x minus a, so on. My function is, f of x. If I plug in a to both of these, they should match. That tells me a0 is equal to f of a. The first derivative should match too. So the first derivative of y is a1. And then the next term would be 2a2 x minus a squared. The third term would be 3a3, excuse me, this should be x minus a to the first. I took the derivative. 3a3 x minus a squared, and so on. Then I take a derivative of my function, f prime of x. These two functions should match if I plug in a. So that says that a1 is f prime at a. The second derivatives need to match as well. So second derivative, this is going to give me the derivative of a constant is 0, and then this next term, the derivative is going to be 2 times 1, a2. I'm going to write that as 2 factorial a2. The next term would be 3 times 2, a3, x minus a to the first. The term after that would be 4 times 3, a4, x minus a squared, and so on. I take two derivatives of my function, get f double prime of x. These two need to match. So that tells me 2 factorial a2 should equal the second derivative of f evaluated at a. So this pattern is going to continue until I get to the ith derivative, or the kth derivative. Let's do k. So the kth derivative is going to be k factorial ak plus more terms involving x minus a. So all of these remaining terms will have at least x minus a to the first power, if not higher, in them. Meaning, when I plug in a for x, these terms go away. I have the kth derivative of my function. These two have to match, so that tells me k factorial ak is the kth derivative evaluated at a. So this tells me the formula for my coefficients. This tells it to me. So therefore, I know that ak, this kth coefficient, is the kth derivative of your function divided by k factorial. Let me use this and write down the entire polynomial. So this tells me my polynomial y is equal to f taking 0 derivatives. That's just going to mean do nothing. Evaluated at a over 0 factorial. This is the 0th term. This is a0. Remember, we define 0 factorial to equal 1. So 0 factorial is equal to 1. This is really just saying a0 is f of a. The next term, the first derivative at a divided by 1 factorial, and then I have this x minus a to the first power, to the first power. The next term, the second derivative at a divided by 2 factorial, x minus a squared, and this pattern continues until I get to the last term, which would be nth derivative divided by n factorial, x minus a to the n. So that's a long formula. It's a lot to write down in expanded form. So just to write this down in an abbreviated fashion, I can use sigma notation. Sigma notation just means add all these things up. So I'm going to add things up, k going from 0 to n, and I'm going to write down the kth term. So here's an abbreviated notation for the degree n Taylor polynomial. All right, great.